Good morning. This is our first primary math recorded lesson. This is the third time I've tried to record it because there's always been issues. So if I do miss something and you don't understand, please message me on the line group. I am available for any questions. And yeah, I'll repeat this at the end of the video, but any feedback you have, please let me know. Am I talking too fast? Is it going too short? Is the video too long and boring? Please let me know open and honestly. Also, the format of what we're doing hasn't been cemented yet. This might not be the way we do it on Wednesday. Let's see. I'm recording this on Monday before we've really discussed how this is supposed to work. So, just so you can get the pages ready, we're going to be going off of page 39 and 40 in the textbook, the Inside Out textbook, obviously. So, continuing talking about angles, here we've got two beautiful straight lines, two vertices that are intersecting at exactly vertical and horizontal positions. You might recognize this slide from last time we were in class because we didn't really get as much done as I would have liked. Laser pointer. So, each of these angles is a right angle and is valued at 90 degrees. The total here for this entire angle, or this circle essentially, if we take it from this point here and we run it all the way around to there, and we'll just put in another straight line here. The value of this total angle is going to be how much? How much is in a circle? I will pause periodically for you to answer. Feel free to just answer out loud in your own home. I don't just want to talk at you. I want you to shout at the screen. Tell me the things you already know, because that's the only way that I will know. So, 360 degrees here, as you know. But you also need to think about it like sets of straight line angles, okay? So we can cut it like this, and these two angles will give us a straight line angle. What do all the angles in a straight line add up to? Well, they add up to 180, you're quite right. So, in the full circle, it would be 360, but for just a straight line, it's 180. And in this case, we can see it because 90 plus 90 is 180. And let's change color. If I cut it here, we also have two straight line angles. And just with these two 90s also add up to 180. And we can keep going around here, and each time we cut it, we get a straight line with two angles, which necessarily must add up to 180. So I know that looks a little bit scrappy and messy, but yeah, think of it like a puzzle. You get free information when we have two straight lines that cross each other, and the free information is that the angles that are next to each other on that straight line that are crossed by the other straight line have to add up to 180. And the same is true if we the same is true if we get rid of this side. This highlighting function is really cool. The same is true if we get rid of this side. So pretend there is only this straight line and this straight line. Again, all the angles in the straight line have to add up to 180. Now I need to get rid of all this. There we are. Cool. Okay. So, in each of these examples, all of these very different angles always have to add up to either a straight line, if we're looking at just the straight line, or if we're looking at the entirety of the circle, then it has to add up to 360. Okay? It's not quite right to think about it like a circle going all the way around. you know, it's not really a circle. What we're actually doing is we're taking a point like here, and we're going all the way around from it, and then back round to it. It's just that these two lines that start and end it are the same line and are the same exact point in space. So it basically is a circle, but you know, it's kind of going all the way around. It's from a point to a point. It's not just a picture of a circle. This is why my videos end up being so long. I need to streamline. Okay, so yep, as we know, all the points in this essentially circular angle, the all the way around angle, add up to 360 degrees. So when we have an example like this, and we have 4 angles, if we know 3 of them, we can quite easily find the other one. Can you remember how we do that? Well, yes, exactly right. We know that the total has to be 360 degrees. So to find A, we can just add all of the sides we know together, take it away from 360, and we'll find A. And that's precisely what we do here. We know, aha, all of these have to add to 360. Yes, they do. So angle A would be 360 degrees minus the blue area here. And that's going to give us A. Let's call A purple. So A could be 120 over here. Yep, and if you add all these together, that will come to 360. Cool. Yes, and for this bit of the equation, remember when you're writing it to put brackets in, just to help yourself remember that all of these happen first and then they get taken away. Because order of operations wise, generally we start from left to right. So otherwise you're doing 360 minus 85. If there's no brackets, I mean, you would be doing 360 minus 85 plus 75 plus 80, and it would be wrong. Right. Keep going. So I don't want to take too much time on opposite angles just now, but as we've discussed this before, you've discussed it with Teacher Rod, we've talked about the angles that are opposite when 2 straight lines meet like this, like 2 swords clashing. The angles that are opposite each other will be equal. D and B. And then the pairs of lines, of angles that are next to each other must make a straight line. They must make a straight line angle like this. They have to be equal to 180 degrees. So A plus B is equal to 180 degrees. B plus C is also equal to 180 degrees, as is C plus D and D plus A. So all of these have to add together to be 180, and they will also necessarily be equal the angle that is opposite to it. Yeah? Right, let's do a couple of very quick examples here. So again, in a straight line angle, the angles don't add to 360, instead they add to 180, quite right. So here we've got B and 70. To find B, we take 180 and we take away this bit here. We take away this angle, which is 70. So we just do 180 minus 70, which gives us 110. Oops. 110. Very easy. Next, we've got, again, what kind of an angle is this here? This is yes, it's a straight line angle. So it has to equal 180 degrees in total. So if we know that this angle here is 35 degrees, how can we find this one? So what, I'll give you a second to get the answer yourself. 5, 4, 3, 2, 1. Yes, it's 180 degrees minus 35 degrees, which will give us 145 degrees. So let's do some examples together. starting off with just straight lines, although we will use straight lines in a lot of these examples. So here, oh, this is the example from across the page. So we've got A plus 35 degrees makes what kind of an angle here? It's a straight line angle, you're right. So it has to be 145, yes. For the next one, for B, here we have 3 different angles. And we know one number. Oh, what's this down here? That's a right angle. Yes, the value of a right angle being 90 degrees exactly. So we know that this bit here, no, oh, I didn't mean to cut the 22 in half. Let's try that one more time, shall we? Yeah, so this angle here, if we combine these together, how much will that be? That'd be, whoa, what happened there? I'm sorry, I'm really not used to writing with a thingamajigger, a mouse. That's a laser pointer! Ah! Right, 22, and then if we add 22 and 90, we get the total of this area here. So 22 plus 90 is going to give us, yeah, it's 112. Cool, so we know the total of these 2 angles is 112. And what kind of an angle is this here? Why, yes, it's a straight line, and a straight line has to equal 180. And we want to find B. Let's just draw B in very quickly as well, okay? So B is here. So, to find B, we take 108. Oh, no, that's not what I meant to do. Oh, that's fine. We take 180, which is the total, and then we do minus 100. I said 120, that's not 120, that's 112. 112, thank you very much. Okay, so 180 minus 112. Answers in 3, 2, 1. That's going to be 68. And again, we can put that into one total equation as well. I was just breaking it up for the visuals here. Now, down here, we have 116, and we have 3 angles that we don't know. Well, how are we going to find out the other angles if we only have 1? Can you see anything special about this? Aha, yes, you're quite right. We have straight line anglers here, don't we? 116 and D together make a straight line. And what's the value of a straight line? Indeed, so we can do 180, and then we can take away 116, and that's going to give us, how much? 64. When I'm 64. So D is going to, that's a 4. Okay, that's the big 4. That's the big 6. So D is going to equal 64. Now, some of you who remember your your corresponding and alternate angles can now tell me the value of these. But for those who can't remember it, let me try and jog your memory to say that D and C also make a straight line. So if D and C make a straight line, then C is going to need to be 180 minus 64D, because they have to form a straight line. Which means that C equals 116, which is the same as the opposite angle here. And changing colors one more time. That means we've got another straight line here. Sorry, this is getting a bit messy. We've got another straight line here, C, and this, which I'm going to call P, because I'm CP, sleepy. So C and P, they are also going to be 180 minus 116 equals 64. So which means that P is going to be 64. So that gives us our pair of opposite angles. And the reason that they're opposite and equal is because we've got all these straight line angles. Yeah? So, relatively straightforward. Again, we're not doing too much on this today, but it's useful to have in the back of your mind. Now next, we need to find out E here. Cheeky wee E. E, we've got E, and we've got two other angles. We know the value of the other angles, so how can we find E? Is it a straight line? No. This is, in fact, basically a full circle here, isn't it? This is, what's the value of that? The value of that is 360, of course. Just get rid of that because it's super messy. So all this has to equal 360. We've got the other two angles, so we can just do 360. Let me draw in this. We want to take away these angles here, so we do 360 minus, and let's give ourselves some brackets, 80 plus 135. Ta-da! And that's going to give us 145. Easy peasy, right? Okay. Well, up here for F, that looks basically the same, isn't it? We know the value of 3 out of 4 of the angles, so we can find the fourth one very easily. We're going to get the total of these and take it away from, yes, exactly, 360. So we just go 360 minus 110. Let's do our brackets. Plus 120 plus 45. Which is going to equal, oh dear, doing maths in my head. So 230 plus 45 is 275. So 360 minus 275. Have to cross that. Have to cross that. So 5, 2. That doesn't look right. That doesn't look right at all. Oh no, that's not yeah. Let's check our answer. No, 85. What did I do wrong there? Get rid of my nonsense. Yeah, 45 plus 85. Okay, I don't know what happened there. But we had the right working. Okay, let's get on to the slightly harder ones. So in this one, we've got 5 different angles, but we only know one actual value. Well, hang on, there's a second value here we can find. What kind of an angle does this little square mean? Yes, it means a 90-degree angle. Easy peasy. So we've got 60 and 90, but now we've got 3 angles, and they're all called G. Why do you think we might have 3 angles with the same name? Well, that's because each of these angles is equal. G means a number. So let's say G meant 60. Well, 60 is a bad example, we've already got 60. Let's say it meant 50. That would mean this was 50, and this is 50, and this is 50, because they're all equal. They've all got the same name, essentially. Okay? So, with that in mind, let's first find the bits of this that are not G. We find that out by doing 90 plus 60, going to give us 150, right? Straightforward so far. And then the total value, oh, that's bothering me how nasty that is. So the total value of all these angles is going to equal what? Oops. the total is going to equal 360, right? So we do 360, and then we can take away 150 for this area here. It's going to give us, how much? 210 degrees, okay? Well, now we've got the problem of the 3 G's. If we've got 3 G's, that means that the total of G, let's change color, the total of 3 G's is going to be 210. So 3G equals 210. How can we find the value of 1G? Well, what we can do is G equals 210, there we are, divided by 3. 3G's equals 210. 1G equals 210 divided by 3. So let's do over 3 here, which means that G is 70 degrees. Yeah, 21 can cross, gives us 7. We've got our 0 here, so it's 70. Yeah, easy peasy. Okay, now we've got one last example, and this example looks a little bit hard, doesn't it? But there's a trick to this one. Let's have a look at it. So we've got 148 is this big old obtuse angle here. Then we've got value I, H, and 2H. Well, first thing to notice, I'll give you a second to see if you can see it, but there's something in these lines. 3, 2, 1. Yes, this is a straight line angle, isn't it? It's crossed at the same angle by here. So this is 148. What must I be? Well, what's the total of a straight line? A straight line's total is 180. Then we just take away 148, and that's going to give us, how much? 32. So I is 32 degrees. Let's put some more degrees around the place just to make it look a bit nicer. Anyway, so 32 degrees is here. Next, we need to have a look at our eyes and our 2 eyes. Well, hang on. Have a look at this. We've got another straight line angle here. We can put a straight line here, which means that I, H, and 2H all equal how much? 280 degrees. Exactly right. So that means that to find how much H and 2H are, let's deal with 2H. Let's go back and deal with 2H just now. So 2H, those of you who are very knowledgeable mathematicians may already know 2H, what that means. 2H just means H multiplied by 2, or that there are 2 H's, okay? So we can basically just chop 2H into 2 pieces, each of which is equal to H. And let's get rid of our 2H here. Okay? So that means we've got H, H, H. H, H, H. Each of those are equal. And we've got I. So, to find out what 3 of the H's are, or 3H, we can do 3H equals, well, it's going to be 180, isn't it going to be? 180 minus 32. Oh, hang on. That's the same as 148, isn't it? So 3H equals 148. And that checks out if we look at this like it's 2 straight lines that intersect. So these meet at straight lines here. So I is actually going to be equal over here as well. And that means the remaining space is equal to 148. So now we've got 3H, which is 1, 2, 3 here, all equaling together in total 148. how can we find out what 1h equals? H is going to equal, can you figure it out? All of these together equal 1, 4, 8. They're equal, so we do 1, 4, 8 over 3, divided by 3. Now, that's a little bit of a complicated one to do on the, oh, no, that's all caps, on the bit here. So let's just bring up our calculator. I'll do it one more time, even though you all just saw the answer. So 148 divided by 3 equals 49.33333, or 3 repeating, okay? So H equals, why is that so, anyway, 49.3. R for repeating degrees. Easy peasy. Now, the questions you're going to be doing in your book are easier than these, although it's good to do together, and maybe we can do some challenge ones later. So, turn to pages 39 and 40. Have a go at them. They're relatively straightforward. If you have any issues whatsoever, please let me know. And that'll be us for just now. 26 minutes. I did not manage to make it any shorter. Okay. Feel free to give feedback, and that's us for just now.